Turn to page 34 of the Weather and Water textbook.
Dragon's breath. Did you ever breathe out a big breath of steam, just like a dragon? It's great fun to exhale a cloud in front of your face and pretend that you can scorch the countryside with one blast of your mighty breath. But you can't perform this trick all the time. Why can you see these breath clouds sometimes, not all the time? That short-lived dragon's breath is a little cloud. What are the ingredients you need to make a cloud? Well, you need water vapor in the air, temperature at or below dew point, and a surface on which the water vapor can condense. Let's look at the variables one at a time. Water vapor in the air. There's always water vapor in the air. Sometimes there is very little water vapor, and sometimes there is a lot. Water vapor in the air is called humidity. There's a definition there. Water vapor in the air is called humidity. Temperature plays an important role in humidity. The rule is, the warmer the air, the more water vapor it can hold. At 35 degrees Celsius, a kilogram of air can hold 35 grams of water vapor. That same kilogram of air at 0 degrees Celsius can hold only 3.5 grams of water vapor. When is air holding as much water vapor as it can, it is said to be saturated. Another definition. When air is holding as much water vapor as it can, it is said to be saturated. When air is saturated, no more water vapor can enter the air. The amount of water needed to saturate a mass of air is not the same at all temperatures. Let's think about a kilogram of air that is holding 3.5 grams of water vapor. The 3.5 grams of water vapor will saturate the kilogram of air at 0 degrees Celsius. That same 3.5 grams of water vapor, however, represents only 10% of the 35 grams needed to saturate the kilogram of air at 35 degrees Celsius. The amount of water vapor in the air compared to the amount of water vapor needed to saturate the air at a given temperature is relative humidity. Relative humidity is reported as a percentage. Once again, another definition. The amount of water vapor in the air compared to the amount of water vapor needed to saturate the air at a given temperature is relative humidity. Next paragraph. The relative humidity of the kilogram of air holding 3.5 grams of water vapor at 0 degrees is 100%. When the same kilogram of air with the same 3.5 grams of water vapor is heated to 35 degrees Celsius, the relative humidity is only 10%. Well, ask yourself this. Look at that chart. Where are they getting these numbers? Well, if you look at that chart very closely, you can see it is the water saturation points, grams per kilogram. Okay, so you look on the left side, it tells you the air temperature, and on the right-hand side, it tells you how many grams of water per kilogram of air is needed to saturate it. Page 35, dew point. Picture the kilogram of warm 35 degrees Celsius air holding 3.5 grams of water vapor. That's 10% relative humidity. This is a cartoon of 3.5 grams of water vapor in the air compared to the 35 grams of water vapor needed to saturate the air at 35 degrees Celsius. So looking at that first diagram, on the left-hand side, you see the same volume here between both pictures, both squares. On the left-hand side, you see just a few air molecules of water vapor floating around within that volume of air. Therefore, it is 10% relative humidity at that temperature. On the right-hand side, the 100% relative humidity. That means it's holding as much as it possibly can. And that as much as it possibly can is 35 grams. Next paragraph. As the kilogram of air cools off to 20 degrees Celsius, there are still 3.5 grams of water vapor in the kilogram of air. But at 20 degrees Celsius, a kilogram of air is saturated when holding 14 grams of water vapor. So looking at that next diagram, you can see the 3.5 grams over here compared to the 14 grams of water vapor in the same amount of space or volume in that kilogram of air. The one on the left is now at 25% relative humidity, and the one on the right is at 100% humidity. Well, how did it change? Well, the temperature dropped. It's now at 20 degrees Celsius. At a lower temperature, it can't hold as much. Next paragraph. At 10 degrees Celsius, a kilogram of air is saturated when it is holding 7 grams of water vapor. When our kilogram of air with its 3.5 grams of water vapor cools to 10 degrees Celsius, the relative humidity is now up to 50%. So as you can see, here and here are definitely different than the ones that are going off here. If the mass of the water vapor in a kilogram of air doesn't change, its relative humidity goes up as it cools. When it gets to 0 degrees Celsius, an interesting thing happens. Without changing the mass of the water vapor in the air becomes saturated. The kilogram of air can only hold 3.5 grams of water vapor at 0 degrees Celsius, and that's the amount in our air. So we're at 100% relative humidity at 0 degrees. Both of them are at 35. Once again, the temperature has changed. Now it can only hold 3.5 grams, so it is at 100%. What happens when the air gets even colder? The table shows that a kilogram of air at negative 10 degrees Celsius can hold only 2 grams of water vapor. Our kilogram of air has 3.5 grams of water vapor. What happens to the extra 1.5 grams of water vapor? It condenses into ice crystals. The temperature at which a volume of air is saturated with water vapor is known as dew point. Here's another definition. The temperature at which the volume of air is saturated with water vapor is known as dew point. When the temperature drops even a tiny bit below the dew point, water condenses as ice crystals, dew, fog, or clouds. Condensation surface. Water vapor needs a surface on which to condense. When the air reaches dew point, water will condense on grass, leaves, and windows as dew. Dew is a thin layer of tiny drops of water. Dew forms on large surfaces. But what about fog and clouds? Here too, water vapor needs a surface on which to condense. In the case of fog and clouds, the surface is microscopic. It can be as small as a piece of dust, a particle of smoke, or a tiny crystal of salt, and all these things are found in the air. Small particles on which water vapor condenses are called condensation nuclei. Here's a definition. Small particles on which water vapor condenses are called condensation nuclei. The air is full of tiny things that can act as the nucleus around which condensation starts. Once a droplet is started, more water vapor can condense on the surface of the water droplet. Well, back to the dragon's breath. Air in your lungs is warm, close to 35 degrees Celsius. Body temperature is 37, so it's very close to your body temperature. And it is humid. In fact, the humidity of an exhaled breath is at or very near 100% relative humidity. Most of the time, water vapor in the exhaled humid air enters the atmosphere and just adds to the humidity of the air. When the warm air from your body is exhaled on a cold day, it cools rapidly. Cold air holds less water vapor. Your breath air quickly drops to dew point and becomes saturated with water vapor. The water vapor from your breath instantly condenses on invisible dust particles present in the air, and you let out a blast of cold dragon breath. The colder the air temperature, the easier it is to saturate the air with water vapor from your breath. So where would you go today to breathe out a cloud? Your face would have to be in the cold, even if the rest of you wasn't. Open the freezer compartment of your refrigerator and blow a blast of dragon breath on the frozen peas and carrots. But be careful, you don't want to defrost the freezer by accident. The think questions. This is what you need to answer. Number 1, what is relative humidity? This is simply asking a definition. Look back and find it. Number 2 has 2 parts. Part A, what is dew point? It's another definition question. And part B, what does dew point have to do with the dragon's breath? Well, take a look back in the article and try to figure out where you would find out dragon's breath and dew point come together. Number 3, why does fog form on bathroom mirrors and car windows? Now, this is not answered directly, word for word from the article, but if you understand the article on what causes things to condense to make fog or on mirrors or car windows in your past experience, and then understanding this article, that should be pretty easy. Number 4, on what kind of day would it be possible to create frozen dragon's breath? So you need to tell me the type of day that it would be possible to create frozen dragon's breath. Please answer in complete sentences. It will make a lot more sense to you.